Well, here we are finishing part two of the build of the RAM for Ben Eater's 8-bit breadboard computer project. In the last video, we actually put together this line of chips, the two memory chips, each of them containing 16 4-bit memories, and then cascaded together we get our 16 8-bit memories, which is the RAM for this computer, 16 bytes of RAM. The two chips following them, I don't think I mentioned before, are inverter chips, because these particular memory chips have inverted outputs, so we have to invert them again to uninvert them. And then finally there's the buffer chip to when it's activated, it puts the value in a selected value from memory out on the bus. Now previously we were selecting addresses in memory by shifting wires around, the yellow control wires, if you'll remember from last video. Now we have this taken care of by a dip switch up here that has 4 switches in it. The dip just means dual inline package. It's the type of packaging for the switch that allows you to plug it into a breadboard like this or into a circuit board. And so right now its address is 0000. All the switches are down, and all these LEDs which indicate the address, these green LEDs are off, indicating 0000. So what we would put into all of these locations, including this first one, are commands for the program that the computer will ultimately run. And so this is in assembly language. This LDA means load a value into register A. If you'll remember, we have register A, register B, and the arithmetic logic unit from a previous video. After that, notice that this command has an argument. The argument is referring to an address in this same RAM memory, address 4, and that's where the value is that you're going to load into register A. And the next command is an add command, and it means add a value which is in memory address 5 to what you put into register A. Okay, the following command is output that, and it will be output to 7-segment displays of the result of that addition problem, and then halt. So the program would stop execution. And then following those 4 addresses in memory are the 2 addresses for the values that are going to be loaded into A and added to the value that we loaded into A. To do all this assembly language in machine language, we just have to have values for the instructions, and they're just numbered from 1 to 15, though there are only actually 5 instructions in the original simple as possible machine, and Ben Eater adds another instruction or 2. But this is what programming looks like, and just as an example, we'll enter into address 0000, which we already have selected over here. We'll enter in the command and the argument of the command here. The 0001 is load data into register A. So here we have a dip switch with 8 switches in it. There's 0001 for the instruction, and then the most significant bits are the instruction, then the address in memory of the value to load into A, which is 0100, or 4 as a decimal value. The way that we do this programming manually is just to press this push button. All these LEDs light up, and when you release the push button, then there's our command. There's our 0001 for the instruction and 0100 for the argument. Then if we go to another address, if we move our dip switch here and go to address 1, for example, well, there's nothing in there. Go back to memory 0000, and there's our value that we put into it stored. It will be stored until power is disconnected. This is volatile RAM, so once you disconnect from power, then have to program it all over again. So next up is building the output module, which will have the 3 7-segment LEDs, and so that will be for next time.
Well, smooth move, X-Lax. You forgot to tell him how to take it out of programming mode and put it into run mode. Why don't you try that, moron?
Well, as the possum and the peanut points out, yes, everything that we were doing in the last video, last part of the video was programming, and this LED indicates that we're in programming mode. Here's a slide switch. If we take it out of programming mode, now it's in run mode, and now any values that were being accessed in RAM or put into RAM, that would be values that were coming from the bus, or the RAM values would be being loaded out onto the bus to be used somewhere else. So that's a good point, Possum. We do need this way to switch back and forth from run mode to programming mode.